In Zoltán's presentation, you will explore the essential steps to ensure your Orchard Core app remains rock solid. You will see how you can use open source tools in the following areas: CI buildings, static code analysis, unit and UI testing. And I hope you will enjoy this session as well.
Thank you very much for the introduction. And yes, why I wanted to give you this talk, because I think that most of the attendees here are doing QA still too manually. I think you are spending still too much time on clicking around the application after some change to make sure that everything still works. I think you are still spending too much time on code reviews if you are doing that, or you are waiting too long as an author of a pull request to get results from a code review. Now, not everything can be automated, but a significant part of QA, quality assurance, can. And I would like to give you a brief intro of the tools available already for Orchard that I think pretty much everybody in every Orchard Core application with every project should utilize. So, oops. If you would like to follow along, I pasted some links into the chat that I now actually also sent. So that's where there's the demo application, the demo solution, all the codes that I will show you, but there are also links to some further reading if you are interested. This won't be a full tutorial. So a little bit of introduction about me and about the rest of the talk. You have probably seen me already. On GitHub, I go by the nickname Piedone. So you have perhaps seen my issues, comments, pull requests, other contributions. I'm, of course, from the company Lombic. You have perhaps also seen a lot of the contributions and activities of Lombic. Perhaps you have also seen the Dojo course, the Orchard Core tutorial series, where I'm the head that talks throughout all the videos. Now, in this talk, we'll focus on Orchard Core. So QA and specifically testing that will mostly be the part of this talk is a large topic. We won't cover everything. We'll just focus on what's suitable for Orchard Core and what's tailored to an Orchard Core application. I will use specific terminology that I will always try to explain, but be aware that when it comes to QA terminologies, it's not black and white. Sometimes the same thing means something different in other contexts, or people are just using the terms differently. But yeah, just a word of warning. And as mentioned, this won't be a complete tutorial. Other tutorials, docs, etc. are available if you want to go into each of these topics deeply. Because what we'll talk about is, well, there's a testing pyramid. What I will present here is more like a mug shape, I think. We will start by introducing the first line of defense when it comes to automated QA, static code analysis. And then from there, we'll build up to higher and higher level of QA. Most of this will be wrapped into continuous integration builds that I will also introduce. And at the end, we'll have an excursion to how to discuss how to collect telemetry for your production application. That's not really automated QA, although it's part of QA, but I think it's quite important to discuss because it's very useful. All right, so let's see the whole thing in action now. First thing, static analysis. Now, have you used static analysis before? Make your guesses, and the answer is that this is a trick question because you actually have. If you have done any work for .NET, specifically C# at least, then you have used static analysis because the green squiggle lines you see in Visual Studio or some other IDE, now that's static analysis. the build warnings coming from MS Build and Roslyn, the C# compiler, are usually, not every time, but usually some kind of static code analysis as well. Because what static code analysis is about is checking your code for potential issues, much like somebody during a code review would. So static code analysis tools can point out all kinds of issues with the code, starting with the basics, formatting rules, whether the code conforms to the formatting conventions you have, or other naming conventions, for example. There are more involved code quality rules as well, like are you checking for no references? Are you disposing NI disposable properly? And they can also point out security issues, not just in C# in general, but also in specifically in ASP.NET code. Now, we have created multiple projects to aid with this in Orchard Core. So while the concept of static code analysis has nothing specific to Orchard Core, of course, but we have tailored some existing tools to be better used with an Orchard Core application. So enough talk until now. Let's actually see the whole thing in action. And what I will use here is the Lombik.NET Analyzers project. This is a kind of a collection of .NET static code analysis packages configured so it conforms to what we usually do in our Orchard Core application. It doesn't contain analyzers itself, but rather it references some quality analyzer projects, including some from .NET itself. I will also use another project called Node.js extensions. This is static code analysis for JavaScript, SCSS or Sass, and Markdown. Now, these are all open source projects, and I'm mentioning these not to make this into an advertisement, but to my knowledge, these are the only projects that provide these kind of features tailored for Orchard Core applications. And of course, feel free to fork and contribute or do anything else. But now let's go to Visual Studio and let's try some C# static code analysis. This is a fairly standard Orchard Core application. You see we have some test projects here that I will talk about. We have a web project with Orchard Core, a theme, and a module. So let's actually go to the module first, and let's check out this service. The code that I have here is not really complicated. This is called an iContent service and its corresponding implementation. This is a service to manage some content. It's not meant to be too useful, rather an example that we'll use throughout this session. And you see it uses iContent Manager. So in a method, it retrieves content items with iContent Manager here, and it does some checks on the inputs. So it actually also throws various exceptions if there's some issue. It also has a second method to change the display text of a content item. Again, something simple, just to give you an idea. And you see that we have a lot of green squiggly lines here. Let's actually check out the error list here and see what the issue is, because these are all static code analysis issues. Well, remove unused local variable. It seems that I left something here. This is a useless method call here. You see that the method, this get content item as row internal, is actually used a line below. So this looks like a leftover. It's a good thing that I got a static code analysis violation for that, because otherwise the reviewer, after I submitted a pull request for this, would have pointed out this. And perhaps the reviewer would be quite sarcastic that, hey, Zoltán, that was quite a rookie mistake. There's another issue here with the name of this method. You see there's a convention that we suffix the name of methods that are async in .NET with the word async. And I've actually used this convention here, but I forget to do for this method. So let's fix that. Okay. Yeah. And like 1-2 seconds after that, the code analyzer will also notice the fix. There are also 2 violations actually for the same thing for this to-do command. Having such to-do commands in your code is quite sloppy because your code will be riddled with little tasks. But it's much better, even if you are working alone, and especially if you are working in a team, to have some kind of central management system for this, an issue tracker, some kind of task manager, a Kanban board, something like that, instead of all these to-do commands. So this is bad. Let me remove this and let's pretend that I actually created an issue for it. And finally, there are also some violations about this interface not being documented. Now, documenting your code like this is always a good practice. What we enforce here by default is documentation for interfaces, because interfaces are usually created for some bigger reusable piece of logic. So it's important to have some kind of documentation at least there. But I actually won't take any time during this talk just writing documentation, because you probably already know how to do that. Rather, I will, for this moment, suppress this this analyzer violation in an attribute. You see, this is possible to do quite easily with Visual Studio context menu. So if there's a false positive for a code analysis violation, or you think that, well, it's not really applicable here, I want to opt out just in this place, then you can add such a suppression. But there's actually also a code analysis to enforce having a justification for this. So I've just added it here. Now, this was C# code analysis, but let's actually take a look at some static resources. So I now go to the theme, and you see that we have scripts and then a CSS file here. And we have static code analysis with the Node.js extensions project for these two. Here in our script, you see, again, we see warnings here. Well, for example, this brace should be rather here. Again, I have an unused variable. I forgot this message here, so I can fix that. And you see there's another suppression here. Usually you don't want your production codes in JavaScript to have console logs, because, well, why would you log to the console of ordinary users? But this is just a demo, so I will leave this here just so we can see that it actually works, but suppress that violation. And similarly, we have static code analysis for SCSS, but unfortunately, that doesn't work together with the error list and the editor in Visual Studio. So instead, what I will do is that I open this Task Runner Explorer. Task Runner Explorer can let you run all kinds of tasks within Visual Studio. Most commonly, it's used to run Node.js build pipelines. So I will use that. As you can see, I'm running the build task here, which will build the JavaScript script. So you do the linting, which is a form of static code analysis there as well, and then run linting for the SCSS file too. And as you can see that, well, we have 2 issues here. Again, a brace styling one, so this should be here. And secondly, this body selector is actually duplicated. Everything in this selector should be in this top selector here. We shouldn't have 2 selectors for the same element. But this is actually just a duplicate. It should rather be removed. So now if I run build again, there won't be any warnings. By the way, I've run the build manually here, but you can also use the watch task. So every time you save the file, the build will run again. And secondly, all of this integrates with MS Build as well. So if you run the MS Build build in Visual Studio as usual, you will see all of these issues. And thirdly, since it integrates with MS Build, it will also be automatically executed during continuous integration builds, which is kind of an important thing that we'll see a bit later. But the last thing is that we also have a README file here in the root. And we actually have linting static code analysis for Markdown as well. If we go to the root project and run the build Markdown task there, you will see that even this Markdown file is not perfect. And you see we have multiple blank lines here, which is ugly, so we should remove that. And secondly, this links title here heading is also a first level heading, just as this one here. That's bad. That's like having two H1s in the same section of an HTML document. That's invalid. So we should do something like fix this and make it into a second level header, or we could also remove it. And now if I run this again, there are no warnings anymore. So this is static code analysis in a very small nutshell. It's very, very useful. It can save a lot of time during code review. And it's not just about code review, it's about improving the quality of your application, of course, for which you get feedback right there in your development environment, and at latest during the continuous integration builds. But before we'll talk about CI builds, we'll talk about testing, because that's the next line of defense. First, we check the code, and next, we actually run the application and see what happens. Let's check out unit testing first. Unit testing is about checking whether one unit, typically a method in a class, produces the correct results. So you provide a method with some known inputs, you know what the output should be, so you check against that. Integration testing, how I use this term here, is something very similar, but in this case, you test the code of the integration of multiple classes. So if a method in your class uses other classes, you also leave those dependencies there, and you also test the other classes. So you test how all of the classes play together, but still just testing the code directly. Now, the advantage here is that unit tests are really fast. You get a result within milliseconds, usually at most seconds. And they're also very specific. So if a unit test fails, then you will know very quickly where your code is wrong, because, well, it's a unit test. The issue can be just in that unit, just in that method. But that's also the drawback, that it's very narrow. It's only testing a few lines of code at a given time. And because of that, you need to have a lot of unit tests to cover your whole application. And still, you are not testing everything. You are not testing how the whole thing plays together. Or you can do that with integration testing. But then you're still not testing how it plays together with Orchard. We'll talk about that a little bit later. Now, when it comes to Orchard core applications, I think you typically test service classes, because that's where most of your complex logic should be. Sometimes you'd have complex logic in controllers, drivers, handlers as well, but I would argue that if you have a lot of complex logic there, if you think you need to test a controller, then that logic should rather be in a service class. What makes this topic Orchard core specific, because otherwise it's unit testing as usual, is that you have to use stubs or mocks for the Orchard core APIs. So let's see what that actually means during our demo. I will go back to Visual Studio, and we will again use our service class. So just so you know what we are talking about, still, here's our service class. But I'm now also opening this test project here. Let me put it below so we can see both things together. Here's our service class, and we want to test it with a unit test. This unit test uses the testing framework XUnit, by the way. That's not mandatory, but that's also what Orchard Core uses. And it's a good framework. Let's see a simple test first. Now, this one is just about testing this change displayed method here. As a super simple method, we want to make sure that when we pass in this display text, it actually sticks in this content item object. So this is what happens in the test here below as well. First, we create an instance of the service class. We'll talk about that a bit later. Just for now, just assume that some instance is created. And then we create a content item, which will be the input of this change display text method here. And we also provide a new display text. And then we do an so-called assertion with this should be method. An assertion is a test where you actually check whether an output or some kind of other behavior is correct. So here we test whether the method indeed changes the display text. Now, this is a simple test, and if you want to be diligent, you would actually have a lot more tests even for just this method. But of course, this is a simple example, and that would be silly. So let's do something else. We can also use inputs for tests. And this is a super cool feature, I think. It's called parameterized tests, or I think data-driven testing is also overlapping with this. What happens here is that we have a test method, and this test method checks whether our getContentItem or throwAsync method throws this argument null exception when the input ID is, incorrect in a way that it's null or empty. Now we could have two test methods for this, one that tests the null input and one that tests the empty string input. But instead, we have this single test method that has a parameter, the ID. And then we use this inline data attributes to supply those inputs. This inline data is XUnit specific, but all testing frameworks have something like this. And the cool thing is that if you check out in Visual Studio Test Explorer how these tests look like, we'll see that for our parameterized test, Visual Studio actually kind of generated two tests. So we have written the code once, but we have actually two test cases. I think that's pretty nice. And now, the third thing here is the most complex one that I wanted to show you, is testing this class with mocking, because so far we only tested the very basic things, but this service actually uses iContentManager. And we also need to test whether it plays nicely along with iContentManager. And that's where it gets a bit more complex. Specifically, we need to use a technique called mocking. And now you can actually see that this create tested service, it's actually should be create content service. I just forget to rename from a training demo. This factory method uses a library called AutoMocker. AutoMocker creates an instance of your class, as you can see here, but does it in a way that it fills the external dependencies with mocks. Now, it's probably time to explain what actually a mock is. A mock is an instance for a usually for an interface that doesn't do anything useful. It's just there. It will seemingly play along with the rest of the code, but it doesn't have any logic. It's just a dummy implementation, but an automatic dummy implementation. So we are not actually creating our own iContentManager implementation just for testing. Instead, this AutoMocker library will do that. Actually, AutoMocker is a library that uses the mocking library mock with a Q at the end. So mock is the one that's creating the mock behind the scenes. And this is important because now we can also test this get content item or throw async method in a way that the input is actually the input ID is actually correct, and it won't throw an exception due to the input, but it will try to run this method here. It will try to access a content item from the content manager. And that's what we do. You see, we do two things here. First, we check whether it throws an exception not due to the input, but here, due to the content item not existing. What actually means that this get async from the content manager will return null. Remember that this iContent manager instance that we are using here will be a mock. So it won't do anything useful. It will return a null instead of an actual content item, unless we set it up in a different way. And because of that, our service should throw here. So that's what we check. And what's even more important for mocks is that you can do a lot of verification with them. You can actually check what we'll do here is that this content manager.getAsync is actually called, that our service actually tries to access the content item. And that's what happens here. This is also an assertion that we use here. From the AutoMocker instance, we get the mock for our iContent Manager instance, and then we verify that this getAsync method was actually called, and not just that it was called in any random way, but that it was called with the same content item ID that we used during our initial get content item or throw async method call. So you see, with mocks, we got kind of a substitute for our iContent manager that's injected here into our service, and we could run some checks on it. Now, mocking is a pretty big topic. You can also set up your mocks to actually do something useful. So we could set up this mock that it indeed returns a content item instance here. So we could do some further tests on our service class, but I hope you get the basic idea. We could talk about this for another half an hour, but instead of going into the details here, I think it's more important to see more examples of automated QA. But now let's actually run the whole thing, because you can run these tests from Visual Studio's Test Explorer, as I'm doing here, or you can do the same thing with the .NET CLI. You can you can do .NET test, and it will run tests as well. You can run tests in continuous integration builds, what I will also show. And you see all the tests pass. That's what we actually awaited. By the way, one term here that might be useful is stubbing. You can instead of using mocking, you can actually create a dummy implementation for iContent Manager yourself. So I could go here and in the test project here, I could create an iContent Manager implementation that doesn't do anything too useful. It just plays nicely along with our service. Now, that has advantages and disadvantages. It's a bit simpler at the first glance, at least, but usually you can't do, without a lot of work, you can't do verifications like this on a stub. However, if you use iContent Manager in a lot of places during testing, and you want to have still kind of a dummy content manager that perhaps stores content items even in a dictionary or something like that, then stubbing can be useful. And we also have a project to help you with that. It's called the Lombic Testing Toolbox. It provides some extensions and implementations for mocking. Because when it comes to unit testing code that's part of an object core module or theme, I think most of the Orchard Core specific work is doing all the mocking, like I did for iContent Manager. Our testing toolbox can help with that. But unit testing is not the only kind of testing. You may be surprised to hear. There's also UI testing. UI testing is, well, as the name suggests, automatically checking whether the UI of an application behaves as it should. And by UI, I indeed mean UI, not just a graphical user interface, but an API is also a UI. A command line interface is also a UI. UI testing also covers that. And this is quite close to what an ordinary user would do. And because of that, at least in theory, UI testing can uncover all the functional bugs in your application. Because, well, it tests really the end result. So if there is a bug, it surfaces somehow, it will surface during UI testing. By the way, UI testing is sometimes also called end-to-end testing or functional testing. These are not necessarily exactly the same thing, but perhaps you know those terms. And UI testing can uncover a lot more. If you change something in the look and feel of the application, UI tests can also uncover unwanted changes. If there are incompatibilities between different browsers or different operating systems or even different hosting models, those can also be uncovered by UI testing. Some of the concurrence and performance issues can also be uncovered by UI testing, although for those there are specific kinds of tests. And what's cool here that we have seen assertions in our UI unit test. So there were specific checks, you know, these should be and should throw calls. We specifically checked whether the output is correct. Now, during UI testing, we do that as well. So, for example, we check whether the menu is there and it contains the menu items we want it to contain. But it can also have some implicit checks that automatically run during every page load. Specifically, what we have implemented is automatic assertions for accessibility issues. So your application is usable for people with disabilities. It follows accessibility guidelines. There are also automated checks for the validity of the HTML output. And it can automatically check the logs as well. The browser logs, so whether there are JavaScript exceptions, for example, and also the Orchard logs. Now, this is all super cool, but there are also downsides, of course. UI tests are much, much slower than unit tests. We are talking about multiple seconds, sometimes multiple minutes even. And they are not specific at all. When something breaks on the UI, you basically have to debug the issue. A UI test won't be able to tell you which class is affected or which input is causing that specific method to throw an exception. So that means that it's a good tool for umbrella checking or testing everything, but you will take a lot of time when it actually finds an issue. I would argue, though, that UI testing is perhaps more important for Orchard Core apps than unit testing, actually, because most of the code that you write for an Orchard Core app will be either UI code, actually, or it will be some plumbing utilizing Orchard Core APIs. And now you don't want to check Orchard Core itself when it comes to lower level code testing. So that means that a lot of your plumbing code, either you have trivial tests or you are not testing them. But UI tests can solve that. So let's actually this in action as well. And you might be surprised, but for this, I will also use a Lombic library. As Sebastian mentioned, we have a library for everything. The library I will use is this UI testing toolbox, which contains a lot of stuff to be able to UI test your application. So I will go back to VS now and open the UI test project, because we also have one here. And this is how a UI test looks like. This is also using XUnit, and as you can see, it looks like a test class. It's also theory, which is an XUnit term, but in the test, we are actually instructing a browser. We are sending commands to a browser, like go to this URL, fill in this text box, or click on this button. And this test here actually tests the login functionality. So let's actually run it and see what happens. I will open the Test Explorer again, and oops, let me try this again, so perhaps we'll have a vertical or a horizontal scroll bar. Well, no, no, here it is. So I will run this test with the debugger and show you what happens. We'll run it command by command, so we can actually investigate in detail what happens, because otherwise it would be really fast. Well, UI testing is slow, but still too fast. It's clicking around too fast for you to comprehend what's happening. So now after the build finishes, it will start an actual Orchard core application. So it will start our application in a test host. And first, it will also open a Chrome instance, a completely new one, which is independent of your installed Chrome profiles. And once it starts, it will start with, well, the setup screen of Orchard, because, well, we don't have anything here. It fills out the setup screen, and then it tests, it restarts the application, and then it goes to the login screen and tests that. So we are there. Now next, let's see what happens with this filling with retries. Well, it fills in the username and then the password, and then it clicks on the submit button. Okay, this was the behavior of what we wanted to test, but we also need to do the assertions. So we need to see that, well, we are actually logged in. So for that, we will click on, the test will click on this hamburger menu here to open the admin menu. It will check for the existence of this menu to begin with, and then it also checks whether it contains the correct username. And finally, it will use what we call a shortcut to check whether the user is also logged in. The shortcuts, as you can see, it's coming from the shortcuts module. We have such shortcuts where you want to use some Orchard core behavior, but you don't want to test the Orchard core behavior. Like you want to log in, you want the current session to log in, but you don't want to test the login screen specifically. Then you would use the login shortcut, or there is this shortcut to see whether the user is logged in. And behind the scenes, as I mentioned, there were implicit assertions as well about whether there are any exceptions in the browser log, in the Orchard log, whether the HTML output is accessible, and whether there are any validation issues. And while the test was about the login screen, if you actually want to test built-in Orchard features, you'd rather use this basic Orchard feature should work test, because this tests all the basic features. It tests the login. It tests some content management tasks. It tests whether you can enable and disable features. It tests all the basic Orchard functionality that you can very well break from your module, but that you shouldn't. Now, that was quite fast, so let me run it again. So again, this is a built-in feature of the UI testing toolbox. It does some positive and negative tests on the setup screen, on the login screen. It creates a content item and checks that. It enables a feature and disables it and checks whether everything still works. And finally, I have a third test, which is called a monkey test. Now, ordinary users can break your app in a lot of ways, and monkey testing is about doing random interactions in your app, much like an ordinary user can also do. So you see it's panning and clicking around and trying to break the current page. It can also navigate away, and it can also send in forms etc. So this is very useful to uncover issues that you may never test for yourself, because, well, it's about render interactions. Now, there's also manual testing, of course. Let's not forget about that, but that's not automated QA. But you still have to do that because users can break your app in a way, as mentioned, that you can't imagine. You have to do that. You also have to use the services of real users to check whether you are building the right thing, whether the app is actually something people want. And you can do all of this manual testing even before a line of code is written. You can provide a design or a mock-up to users and see how they behave. But I won't provide a demo with that. You already know how this works. But CI builds is more interesting. CI builds are about automatically building and running the test for your application on pretty much every push, or at least when you open a pull request. And you need this. You need this if you want to do automated QA. It won't work anywhere, in any other way, because if you don't have CI builds, then nobody will run the tests. Nobody will reliably run the tests, at least. So you need it. We'll use our GitHub Actions project for this, which contains a lot of Orchard Core specific workflows, such automated workflows using GitHub Actions, which is the CI and automation pipeline used by GitHub. And we actually have a workflow here, what I will show you in a minute. But even before that, let's break something here. We have our nice service. Let me add a static code analysis violation just by adding an unneeded empty line here. And let's open a pull request for this, because this is such an awesome change. So I will go here and commit this. I will, let's do it with all the changes that I applied. I will create a new branch for this CI test, and I will say fixing analyzer violations. This is, of course, a lie, because I implemented one analyzer violation at least. So now let's go to our test project and open a pull request for that. Yeah, let's call it fixing analyzer violations here too. And let's see what happens. In Visual Studio, we can actually open the corresponding workflow. This is the workflow that GitHub Actions will run. As you can see, it doesn't contain much logic, because, well, it uses Lombi GitHub Actions. It specifically uses the build and test Orchard Core reusable workflow from that. And as you can see, it already started here. And if we open it, we can see that, well, first it checks out the code and does some setup, and then it checks whether the .NET NuGet packages that you have all use all the same versions, and then it starts a build. This will take, I think, 1.5 minutes if we let it run to completion. But it should fail even before that, because, well, we have an error. Now, while this build will fail, let me show you one that actually finished to completion. If there are no issues, this is how a build result will look like. You can see it's nice and green, and we also get a summary of the tests, the test executions that we had, the 4 unit tests here, and the 3 UI tests with all kinds of details. The build is still running, but it will actually fail. The test outputs, by the way, also contain some details about how long a test took. So that's also quite useful to pinpoint whether your tests are too slow. And again, unit tests, of course, win here, it was just a few milliseconds for the unit tests versus a few seconds for the UI tests. And our build finally failed. You can see it failed like this. Everything is bad red. And we can actually see the issues here. Oh, and I I actually opened the pull request for the wrong branch. Sorry about that. So that's why we see all the analyzer violations that I initially had in the code. But you see, all of these violations actually work. And I know that the time has just passed. So the last thing that I wanted to show you, telemetry. Because telemetry is about collecting information about how your app runs in production. It's not automated QA, but it's still QA. You can collect performance metrics, for example, details about every HTTP request, exceptions, everything that goes to the logs. And all of these can be also correlated. I will show you an easy implementation for an easy integration for this with our application insights module here. And application insights is the telemetry feature of Azure. It's not the only one, of course, but that's something that you can readily use. And as you can see, for example, it can provide you with performance metrics. Now, this is just a test app, so not much to see here, but it can also provide you information about failures. And it also has a cool feature called live metrics. This is about displaying what happens in your app right now. So if I log in with admin password here, on the left-hand side, you will see the requests actually coming in. This little thingies here are the requests. If I go to this page, we'll have another request coming in. If I go to the admin, another request. And actually, our module also has a log test feature that you can use to cause an error. And now you see that there's actually an exception that happened here. And if you open up the details, we even see the exceptions details to the right-hand side. There's a lot more features to application insights, but I just wanted to give you a glimpse that, well, you can also collect telemetry for your application once it's deployed, and that's very, very useful too. All right, so that was it, I think. We haven't talked about a lot of things, but that's maybe topics for another day. But I really think that you should start writing tests, and your developers should start writing tests and introduce static code analysis. You also need test engineers, but if you are just beginning, then if a developer creates a feature, implements a feature, ask them to write the corresponding tests as well. That's how you learn. So go home, or if you are already in your home office, just go and write these tests. Thank you very much.
Thank you, Zoltán. And we have 4 questions in the chat. Oh, and I see that there is no, there was a hand. So the first question was that VS Code is such a better experience than Markdown, CSS, and JS linters. Will there be an Orchard Core .testing module?
Sorry, the question is about using Visual Studio Code. I didn't quite understand it. Because for the demo, I use Visual Studio proper, but you can use any editors with these tools, of course. The static analysis tools will also work and display the squiggly lines even in Visual Studio Code or Rider or any other IDE, because they play along with Roslyn, the C# compiler.
I can see in the chat that it was not a question, it was a remark. Sorry,
Okay.
there was a question mark, so I thought that I will read it. And there was another question that what are the differences between stubs, mocks, and fakes?
I've mostly focused on mocks, so that's where you have a substitute implementation for a dependency of your class that you want to unit test, and use something like the Automocker library to automatically generate that substitute implementation, instead of having like an iContent Manager implementation that you create by hand. Now, stubs, as I very briefly mentioned, would be also having substitute implementations that you actually implement by hand. So to have a content manager stub, you would create a class that implements iContent Manager, and when you instantiate your tested service, you would inject that. Now, fakes, I think these are not really used that much nowadays, at least if we mean the same thing under fakes. That would be about providing substitute implementations for statics, for static methods and static classes otherwise, usually when they come from .NET. A typical example here would be datetime.now. If in your code you have datetime.now, then that's a code that you can't really test, except if you actually play around changing the time settings of the machine. But there were libraries to actually still substitute these. Now I think a better option is to do what actually Orchard Core does, to provide injectable dependencies for each of these, which in the case of Orchard Core is iClock, that pretty much wraps datetime.utc now.
Another question was that it using
Sorry, Vicky, I seem to have lost you. Could you please repeat the question? I lost your voice.
Yeah, sorry, can you?
It's breaking up again. I would suggest you disable your webcam temporarily.
Can you hear me now?
Yes, yes.
Sorry, my internet just broke. So
But
the
no,
question
it's
is
right.
that is it using Selenium UI? If not, what are the advantages over Selenium UI?
It does use Selenium, yes. So I didn't go into much details there. This is, by the way, also documented, but the UI testing toolbox, yes, uses Selenium behind the scenes, the .NET bindings of Selenium.
Yes, and there was one more question. Do you plan to support Azure DevOps pipelines?
Not in the near future, especially because it seems that Azure DevOps and GitHub Actions are converging. Well, there were actually statements by Microsoft employees about Azure DevOps eventually being merged into GitHub. So not really. But if you use Azure DevOps and want to utilize something similar, then I encourage you to check out the mentioned Lombi GitHub Actions project, because there are a lot of similarities between these two systems. And if nothing more, you can take it as an inspiration. A lot of the logic in those CI workflows are implemented in PowerShell scripts, actually. So those you can use right away in any system. The rest will need a little bit of migration work.
Okay, thank you. That was the last question in the chat. There is 2 minutes left from the Q&A session, and oh, it's actually 1 minute, and after we will have a 5 minutes break. Oh, there is one more. can you use Orchard Core auto step feature to create a testing database to run the integration test against?
Yes, although there's not much use to use auto setup for this actually. But yes, you can also do that. What we recommend is having your testing database, so to say, just as your development database in recipes. So that's why you have seen the tests starting with the setup as well. You don't necessarily need to use the setup screen, so auto setup can be used there as well. One thing to note though, that if you have multiple tests that use the same recipe, then the setup will be cached. So it will be only run once, and after that, all the other tests will use the same the snapshot of the already set up Orchard Core application and continue from there.
Sorry, I missed Benedek's question, but he reminded me. Can you integrate spell checking with your QA process?
Yes, that's a great question. We have an awesome spell checking implementation for that. I'm laughing a little bit because Benedek worked a lot on that. So yes, actually, if we go to GitHub Actions, there's a workflow called spelling, which uses a very nice GitHub action by one of the GitHub community members that does spell checking. That's also quite useful because spelling errors is also something that you usually point out during code reviews. With all of these practices, where you end up is that when a change gets to the code review stage, you can already be pretty sure that it's quality code and it doesn't break any existing feature. And by the way, there are a lot more workflows and a lot more features in all of these projects. I just wanted to show you the basics, like this one.
Thank you.